Importantly, there are two main ways to subtract: to take away or to count on, which is effectively finding the difference between two numbers. Again, as with addition, the children in Key Stage 1 and early years would use various resources to subtract. Cubes or counters are great for taking away, whilst number lines are best for finding the difference. Even at the early stages of Key Stage 2, we still encourage the children to use number lines, although they more often will have to draw them as they will involve larger numbers. So with the example of 84 take 56, the number line would start at 56 and end at 84. We would then ask the children to jump along the number line in manageable steps until they have counted on to the answer. So in this example, a child would probably count on initially to 60, which would be a jump of 4, followed probably by a jump to 80, which is another 20, followed by the final little step from 80 to 84, which is another 4. And then most children would simply add up those numbers in their head, which would make 28. In the Year 4, 5 and 6 column, you will see that we are still asking the children to count on, but to apply it to a more abstract written method where the number line is in their head. So with this Year 6 example, we would ask them to count on from this smaller number here and record their steps underneath. So my first step might be to count on to 2,700. Although a more confident child may count up to 3,000 with their first step. This step involves counting on 16. From 2,700 I would probably count up to 3,000, which I will record here. And the less confident children will do this. That's obviously added on another 300. And from 3,000, most of the children will probably go straight to the target number now, rather than to 6,000 first and then 6,467. Now that they've arrived at their target number, they simply draw a line and then add up the jumps that they made from this number to this number. Which gives an answer of 3,783. In Year 5 and 6 we introduced decomposition, which many parents will remember as the borrowing method. This provides children with a more compact method for larger calculations. However, it is important to say that it is not designed to replace the counting on method, but to complement it. Capable mathematicians will confidently use both methods depending on the calculation. So using the same calculation, we would start with the units and take 4 from 7, which leaves 3. We can't take 8 from 6, so I'll have to borrow from the next column. I'm not quite sure why we say borrow, because it's not given back, so we take from the next column. So we'll take one of these 400s, which will then become 300s, and give that to the 6 tens. So we've now got 16 tens, and 16 take 8 we can do, which leaves 8 tens. Again, we can't take 6 from 3, so we're going to need to borrow from the thousands column. Which reduces that down to 5 thousands, and give that 1,000 to the hundreds column, so we've now got 13 hundreds, and 13 hundreds take 6 hundreds is 7 hundreds. Finally, of course, take away the 2 thousands from the 5 thousands, which leaves 3,000, and the total once again is 3,783. When subtracting mentally, counting on is for the majority of children the easiest method to use for the vast majority of calculations. In fact, the more able Year 5 and 6 children should be able to do this calculation in their head without the need for paper. Exceptions are when you are subtracting a small quantity. For example, 847 subtract 13, where we would expect the children to take 10 away from 847 and then 3 away, or something similar. Here are a couple of obvious examples of where counting on is the most sensible method to use, and decomposition or borrowing involves a loss of unnecessary work, like this. Clearly it's more sensible to simply count on in your head from 9 to 12, which is 3. And in this example, from 5,985 up to 6,000, which is 15, and then from 6,000 to 7,006, which is 1,006. Add the two together, although of course the children would be expected to do that in their head and not write anything.